After completing this lesson, you will be able to explain the complete training pipeline for large language models, understand what happens in each training phase, recognize which phase adds which capability, understand the data requirements for each phase, know how modern reasoning models, like O1, are created. Large language models like GPT-4, Claude, and Llama don't become amazing in one step. They go through multiple training phases, each adding different capabilities. Mon image. It all starts with a transformer. And a transformer is a specific type of neural network. This part is first initialized with some random weights. So the performance is, of course, very bad if you initialize with random weights. Let's explore each phase. Pre-training is where the model learns language understanding and background knowledge from massive amounts of unstructured text. Goal: teach the model to predict the next token, word, subword, data, unstructured text from the internet, books, code, paper scale. Trillions of tokens, weeks, months of training on thousands of GPUs. The first step in the training process is called pre-training. And in this step, we're just giving the model the objective to predict the next token on some unstructured data in order to make the model gain language understanding and background knowledge. Unstructured means exactly as it appears. No special formatting. No questions, no answers, no instructions, just raw text. The original Llama model was pre-trained on source, percentage, purpose, web data, common crawl, 67%, general knowledge, language patterns, GitHub, 4.5%, coding ability, Wikipedia, 4.5%, factual knowledge, books, 4.5%, long-form reasoning, narrative, Archive, 2.5%, scientific math knowledge, Stack Exchange, 2%, Q&A patterns, technical knowledge. Total, 1.4 trillion tokens. During pre-training, by learning to predict the next token, the model implicitly learns grammar and syntax, facts about the world, Paris is in France, common sense reasoning, ice melts when heated, code patterns and logic, multiple languages, basic math, text completion. After pre-training, the model cannot follow instructions. Write me a poem about dogs. Cannot answer questions properly. What is AI? Cannot have conversations. No concept of turns. Does not know when to stop. Keeps generating. May generate harmful or biased content. Result: a base model that can complete text but isn't useful as an assistant. Supervised fine-tuning teaches the model how to follow instructions, answer questions, and have conversations. Goal: teach the model to behave like a helpful assistant. Data: structured examples of desired behavior. Input, output pairs. Scale: thousands to millions of examples. Days of training. We are actually going to collect a dataset that demonstrates an intended behavior. And one of these behaviors we want the LLMs to have is, for example, that it needs to learn how to follow instructions, that it needs to learn how to answer questions about a domain, learn how to have conversations. According to the Llama 3 paper, SFT included English Q&A, coding tasks, Python, JavaScript, etc., exam questions, STEM topics, creative writing, reasoning problems, conversation examples. After SFT, the model can follow instructions, answer questions properly, have multi-turn conversations, refuse inappropriate requests if trained, format outputs nicely, know when to stop generating, result: an instruct model or chat model that's actually useful. Alignment makes the model better, follow human preferences and be safer. Goal: make outputs helpful, harmless, and honest. Data: prompts with preferred and rejected responses. Scale: thousands of preference pairs, reinforcement learning. Another post-training phase is the model alignment phase, and this is a reinforcement learning phase. The reason that this is done is to make the model better follow human preferences and also make the model safer. The model learns to prefer chosen responses and avoid rejected ones. RLHF, reinforcement learning from human feedback. 1. Humans rate model outputs, thumbs up, down. 2. Train a reward model from these ratings. 3. Use RL to optimize the model for higher rewards. Direct preference optimization. Direct preference optimization. Simpler than RLHF, directly trains on preference pairs. More stable training PPO, proximal policy optimization. Classic RL algorithm. Keeps model from changing too much. For large labs, hire human annotators. For you, large model providers do this by using human annotators, but you can easily do this yourself by just providing an upvote and downvote button on your answers and collecting a data set that way. Llama 3 did multiple rounds of SFT plus direct preference optimization. After alignment, more helpful responses, safer, refuses harmful requests, better at following user intent, more honest, admits uncertainty, culturally sensitive, less biased. Result, a production-ready model like GPT-4, Claude, or Llama 3. GRPO, Group Relative Policy Optimization, is a new technique for creating reasoning models like OpenAI's O1. Goal, teach the model to think step by step before answering data. Questions, plus reward functions, not demonstrations. Scale, math, science, coding problems. Recently, a new post-training phase has popped up, and that's also a reinforcement learning phase, and this one is used to create those reasoning models such as O1. Traditional SFT show the model examples of reasoning. GRPO, just provide questions and define what good means. By defining good reward functions, we can actually steer the model towards those outputs without actually having to collect demonstrations of the reasoning behavior, which is very interesting. So just by defining reward functions, the model learns how to reason itself. Benefits. Don't need to manually write reasoning examples. Model discovers its own reasoning strategies. Can create complex reasoning you couldn't demonstrate. Works for any domain with verifiable outputs. Easy. Verifiable, correct, incorrect. Math problems, coding, does it run? Science questions, factual. Logic puzzles, harder, subjective. Creative writing, how to reward good. Open-ended questions, subjective topics. But you can try. Just need creative reward functions. The model will learn to show its work and explain reasoning to get more reward. Phase, input, output, data type, scale. Pre-training, random weights, base model, unstructured text, 1T tokens, SFT, base model, instruct model, instruction, response, 100K, 1M, alignment, instruct model, safe model, preferences, 10K, 100K, GRPO, aligned model, reasoning model, Q&A plus rewards, 10K, 100K. Pre-training, language, plus knowledge, SFT, following instructions, alignment, safety, plus preferences, GRPO, reasoning ability. Pre-training, trillions of tokens, SFT, millions of examples. Alignment, thousands of preferences, GRPO, thousands of problems. Continue pre-training. Add domain knowledge, medical papers, legal docs, SFT, most common, teach new tasks. Alignment, improve safety, show preferences, GRPO, Add reasoning to your domain. Llama 3. Base. SFT. Direct Preference Optimization. SFT. Direct Preference Optimization. Each round improves quality. One. What does the model learn during pre-training? Answer language understanding and background knowledge by predicting the next token on unstructured text. This includes grammar, facts, common sense, code patterns, and basic reasoning. 2. What's the difference between a base model and an instruct model? Answer. Base model. After pre-training only. Can complete text but cannot follow instructions or answer questions properly. Instruct model. After supervised fine-tuning, SFT. Can follow instructions, answer questions, and have conversations. 3. What data format does alignment training use? Answer preference pairs. Each example has a prompt with a chosen, preferred response and a rejected response. The model learns to prefer the chosen responses. 4. How is GRPO different from traditional supervised fine-tuning for reasoning? Answer. Traditional SFT. You provide examples of reasoning, demonstrate step-by-step thinking. GRPO. You just provide questions and define reward functions. The model discovers reasoning strategies on its own to maximize reward. 5. True or false? You need more data for pre-training than for SFT. Answer. True. Pre-training needs trillions of tokens, weeks on thousands of GPUs, while SFT typically needs thousands to millions of examples, days of training. For each scenario, identify which training phase would add this capability. Scenario 1. Model can complete the sentence, "The capital of France is," with Paris answer. Pre-training. This is factual knowledge learned from unstructured text like Wikipedia. Scenario 2. Model responds to "Write me a haiku about computers" with an actual haiku answer. Supervised fine-tuning. Following instructions to write in a specific format requires SFT. Scenario 3. Model refuses to answer "How do I hack a website?" Answer alignment, direct preference, optimization PPO. Safety behavior and refusing harmful requests comes from alignment training. Scenario 4. Model shows step-by-step work when solving math problems. Answer GRPO or SFT with reasoning examples. Reasoning behavior can be taught with GRPO using reward functions or with SFT using reasoning demonstrations. Scenario 5. Model understands medical terminology and anatomy. Answer pre-training or continued pre-training. Domain knowledge comes from pre-training on domain-specific text, medical papers, textbooks. Based on your project idea from previous lessons, answer. 1. Which phase will you be doing? Continued pre-training, adding domain knowledge. Supervised fine-tuning, teaching tasks, instructions, alignment, improving preferences, safety, GRPO, adding reasoning. 2. Why this phase? What capability are you adding? 3. What will your training data look like? 4. Estimated data needed. Pre-training, 100 mem plus tokens. SFT, 110,000 examples. Alignment, 55,000 preference pairs. GRPO, 110,000 problems with rewards. Example answer. One, training is multi-phase. Pre-training, SFT, alignment, GRPO. 2. Each phase adds specific capabilities. Knowledge, instructions, safety, reasoning. 3. Data requirements decrease, trillions, millions, thousands. 4. You'll mostly do SFT, most practical for custom use cases. 5. GRPO is cutting edge. Create reasoning models with reward functions. Now that you understand the training pipeline, let's learn about the technique that makes fine-tuning affordable. Lesson 1.4, Understanding Low-Rank Adaptation and Quantized. Low-rank adaptation. Want to dive deeper? Llama 3 paper. Training details and dataset mixtures. RLHF paper. Learning to summarize from human feedback. Direct preference optimization. Paper. Direct preference optimization. GRPO. Search for group relative policy optimization.